atoms are neutral. Neutral means they have the same number of positive and negative particles which cancel each other out. The positive particles are protons, the negative particles are electrons. So neutral atoms have the same number of protons and electrons. It can have a different number of neutrons because they're neutral, and a few more or a few less doesn't change the charge on an atom, which is zero charge, neutral. An ion, on the other hand, is an atom that has gained or lost an electron, and that gives it a charge. Well, it has to be the electrons that are gained and lost because they're on the outside. The protons and neutrons are in the nucleus. You can't get to them. You can't grab them and pull them out. Whereas electrons are on the outside and they are easier to pull off. So electrons are what are lost or even gained. Sometimes an atom, they'll add electrons to an atom. The reason an atom gains or loses electrons is to become more stable. And that is why compounds react, or elements react to make compounds, is because they gain or lose electrons by reacting, and that makes them more stable. So now we're going to learn how to sketch an atom and how to sketch an ion. So if we are sketching a sodium-23 atom, so we look up sodium. Now notice what? Sodium is Na? There is no N or A in sodium. What's going on? Well, that's actually based off the Latin word for sodium, which is natrium. So if you ever see a weird symbol, that's why. It's usually based off the Latin word, because they'd already used S for sulfur. And I don't know why they didn't want to use SO. They just didn't. So sodium has an atomic number of 11. So that means there are 11 protons, and mass number minus the atomic number will give you your neutrons. So that would be 12 neutrons. And of course the protons and the electrons are the same because it's a neutral atom, so there are 11 electrons. So we put the protons and the neutrons in the nucleus, in the middle. So 11 P plus and 12 N zeros go in the nucleus. I'm going to switch to a different color of pen for the electrons, so that way the nucleus and the energy levels will look different. So we are now ready for the electrons. When you draw an energy level, you can only put 2 electrons in the first energy level. So 1, 2. In the second energy level, we can fit up to 8. Well, there are 11 electrons total. We've only used 2, so there are still 9 left, but we can only put 8 in the second energy level. 1, 2, 3, 4, 5, 6, 7, 8. So the last electron has to go in the third energy level. You won't see anything more complicated than this, so you can just put all your leftover electrons in the third energy level, if there are any leftovers. So that is a sodium atom. Let's look at the atoms first, then we'll come back and look at the ions. Next, we need to sketch an oxygen-16 atom. So the number of protons, we find that on the periodic table, and oxygen has 8 protons. 16 minus 8 gives us 8 neutrons. Wait a minute, I thought neutrons and protons had to be different. No, they don't. They can be the same or different. It doesn't matter, but you do have to figure out how many neutrons there are because the neutrons can change. Next, the number of electrons is equal to the number of protons. So we have 8 of each. Now we put the protons and neutrons in the nucleus. And in the first energy level, we can have up to 2 electrons. And in the second, we can have up to 8. Well, we only have 8 electrons, and we've already used 2, so we have 6 left. So we just put 6 electrons in the second energy level. There are no leftovers, so we don't need the third energy level. All right, let's take a look at chlorine 35. If you know what you're doing, stop the video and finish this, the 3 atom drawings that are left. But if you don't know what to do, continue watching. So we have chlorine 35. We look up chlorine on the periodic table, atomic number of 17. So that's 17 protons and 17 electrons. 35 minus 17 gives us 18 neutrons. And now we can draw our atom. So we put the protons and the neutrons in the nucleus. Then, in the first energy level, we can have up to 2 electrons. In the second energy level, we can have up to 8. Do we have enough? Oh yes, we have 17 minus 2, we still have 15 left, and we can only fit 8. So let's put all 8. All right, how many do we have left? Well, we have 2 plus 8, we have used up 10. We had 17, oh, so we have 7 left. So we put all 7 in the third energy level. You continue on and finish up the rest of these atoms. Then come back and watch the video to see how to draw ions. First of all, I need to teach you how to figure out the charge on an ion. So here, anything in group 1A gets a positive 1 charge. Anything in group 2A gets a positive 2 charge. Notice the Roman numeral 2A. Skip all the short ones. Down, anything above this stair-step line gets a negative charge. Anything below the stair-step line gets a positive charge. So positive 1, positive 2. Aluminum gets a positive 3. They're not going to ask you about any other elements at this time. Now, these get a negative charge starting with 5. So negative 5, negative 4, negative 3, negative 2, negative 1, and these don't get a charge because they don't make ions. Only boride ions get a negative 5 charge because they're the only one above the stair-step line. Boron atoms make boride ions. All the negative ions end in "ide." So carbide and silicide ions get a negative 4. They're the only 2 above this stair-step line to become negative. If you went down here, these would probably get a positive 4. Nitride, phosphide, and arsenide get a negative 3 charge. Oxide, sulfide, selenide, and telluride get a negative 2. And fluoride, chloride, bromide, iodide, and astatide get a negative 1. So that's what each of these elements changes into when it becomes an ion. The positive ions don't get funny names. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium all get a positive 1 charge, and you don't change the name. All right, so what does this mean? Remember, they have gained or lost electrons to get this charge. Now, electrons are negative. So if you gain a negative electron, you're getting more negatives. That's how an element gets a negative charge. So boride has gained 5 electrons. That's kind of backwards, isn't it? Okay, so just remember, negative 5 means gained 5 because you gained 5 negative electrons, and that's why it becomes negative. The positive ones have lost negative electrons. Losing negatives is like subtracting a negative, which is like adding a positive. So therefore, positive 1 means lost 1 electron. Positive 2 means lost 2, and positive 3 means lost 3. Let's take a look at why that happens. When you have a sodium atom, the sodium, so you have to find sodium on the periodic table, and the ion gets a positive 1 charge. So that would be Na plus 1. The plus 1 is a superscript up in the air. You can also write Na1 plus, or you could just write Na plus. You don't have to write the 1. However, unlike math, you do have to write the positive, because that's very important to know if it's a positive or negative ion. So now we are ready to sketch this ion. It still has 11 protons and 12 neutrons. That hasn't changed. But remember, positive 1 means lost 1 electron. This is the electron that will be lost. So what's left? We have 2 electrons in the first energy level and 8 in the second. The third energy level is now empty, so we just don't draw it. And that 1 electron is gone. And that's more stable because this second energy level is now full and it's on the outside. And a full energy level is very stable. All right, let's look at oxygen. First, we have to find it on the periodic table. Oxygen gets a -2 charge to become the oxide ion. You can write that O-2 or O2-. O2- drives me crazy. Nobody says that, but that's the way that it's going to be on your exam. And so, therefore, I need to teach it to you. There's nothing wrong with it. It just bugs me. I don't like it. But darn it, they didn't ask me. So, 8 protons and 8 neutrons are still in the nucleus. Then, -2 means gain 2. Okay, so we had 6 electrons. Oh, if we gain 2, we'll now have 8, which will be a full energy level. And that's very stable. So we draw the 2 in the first energy level. The 6 we already have plus 2 more, so we draw a total of 8. And that's how you draw an oxide ion. You continue on with chlorine, phosphorus, and hydrogen ions.